In this video, we're going to look at how to form new binomial distributions using answers to previous questions. This is one of the trickiest topics in the course, but it's a lot of fun. Let's have a look at this. Eggs come in boxes of 6. The probability that each egg is cracked is 0.05. Find the probability that a box contains at least one cracked egg. Now this at least one is a little bit of an alarm bell. It's a bit of a classic and one that you should just kind of pop out at you. Because at least one, so the probability that x is greater than or equal to 1, think about what that isn't. Well, if we have at least one cracked egg, we didn't have no cracked eggs. So we can instead look for the probability of not having, so 1 minus the probability of no cracked eggs. And actually we can work out this probability that x equals 0. Of course we can use the calculator, but it can be faster to just think about what it is in terms of, well, in terms of, not even in terms of binomial probability, just in terms of repeated outcomes. So if there are no cracked eggs, then what must have happened on each egg is it didn't break. So the first one didn't break, so the probability of that is 0.95, the next one didn't break, the next one didn't, and the next one didn't, and so on. So that means that it must have had not breaking, 0.95, must have happened all 6 times. So just in one go, we just get straight to our answer. No need to go into the calculator function, no need to use binomial distribution formula even. It's just the probability of it not breaking to the power of 6. So all of that gives us 0.2649. Okay, so that's similar to the stuff that we were looking at before. Now look at the next question. Boxes of eggs are packed into crates of 20 boxes. If a box contains any cracked eggs, it is marked as unsellable. Find the probability that a crate contains at least 4 unsellable boxes. All right, so let's try to describe the distribution here. Well, it is binomial because each box is either sellable or unsellable. And there are 20 boxes in each crate. And then what's the probability that each of those egg boxes is unsellable? Well, it's actually what we worked out in question 1, because they're unsellable if they contain any cracked eggs. And we've worked out the probability of a box containing at least one cracked egg. So this answer to part A is our probability that an individual box is unsellable. And that's what needs to go into our new binomial distribution. Because our new binomial distribution is about 20 boxes in a crate, and then each one of those boxes is either sellable or unsellable, and we know the probability of it being unsellable at 0.2649. And now our question is, what's the probability that at least 4 are unsellable? So that's probability that x is greater than or equal to 4. Well, again, writing out our numbers just to make sure we don't get this step wrong. At least 4 means it's 4 or more, so it's these that we're interested in. So we don't want these. So that's going to be 1 minus the probability that x is less than or equal to 3. So over to my calculator now, and we're going to go to our menu and go to the distribution mode. It's binomial cumulative, not the probability distribution, so binomial CD. We want variable as always. Now it's 3 because it's less than or equal to 3. N is 20 because there are 20 boxes in the crate. P is 0.2649 because that's the probability of each box being unsellable. So there's our answer. So what we need to do is 1 minus that. So that's 0.18305. 0.18305, and obviously you can just key that into the calculator like that, or you can use this nice little trick that I've shown you before where we just store what's on the screen as A, go back to our regular mode and do 1 minus A. And there's our answer, 0.8169. So 0.8169. All right, so as I said, those are some of the more challenging questions, but it's really fun kind of piecing things together and problem solving. So I hope you enjoyed looking at that.